You're welcome to my YouTube channel where I take you through research methodology line by line, precept upon precept, the length and breadth of it. Even if you are a novice, I'll be able to take you explaining it very simply so you understand and love research methodology. In today's video, I'm talking on how you'll understand type 1 error, type 2 error, and type 3 error in research methodology. I am Dr. Abel Simeon. I am the Managing Director of Amom Consulting Limited. I am also a doctoral research fellow at the Corporate Institute of Strategic Research. I am also a director of strategic planning and research at the Institute of Professional Industrialist and Management Development. In this business of empirical research, I have over 29 years experience. So just sit back and I take you through what research methodology is all about. But today we are talking about errors, type 1 error, type 2 error, and type 3 error in research methodology. We are basically considering what type 1 error, type 2 error, and type 3 errors are in research methodology. But please do not mistake it to be that of Neyman, Jazzy, Splawer, and Pearson Egon Sharp error 1 and error 2. To know what I'm talking about, you need to differentiate it. That this type 1 error, type 2 error, type 3 error I want to talk about has nothing to do directly with the type 1 and type 2 null hypothesis errors. The null hypothesis errors of Neyman, Jazzy, and Splawer, Neyman, Jazzy, Splawer, and Pearson Egon Sharp of 1933 is different. There, they were describing false rejection as error 1 and false acceptance as error 2. That's not what I'm talking about here. The false rejection and false acceptance is not what I'm talking about here. I'm talking about objective errors. They are talking about null hypothesis errors. Now, what Neyman and Pearson were talking about is one, they looked at the conventional viewpoint that conventionally, if your alpha coefficient in your study is, say, 0.05, which stands for 5% error or 95% confident, they are saying that in your computation using Carl Pearson's product movement correlation coefficient at PPMCC with the symbol arrow, when you do that computation, either use SPSS or use any other software, if you study the p-value simply means the probability value. If that probability value is less than 0.05, then you should reject that null hypothesis as failure, because it is so, you just reject it, because at this time the computed value, the calculated value is less than 0.05. Conversely, if it is greater than 0.05, there, conventionally, you should accept the null hypothesis. Today's study is not about null hypothesis or alternative hypothesis. It is purely understanding type 1 error, type 2 error, type 3 error. This I'm just giving you a background so that you understand that I'm not talking about Pearson and Neyman's error 1 and error 2. Now, they are saying if it is greater than 0.05, your acceptance of null hypothesis should be sure. Then Neyman is saying, and Pearson, they are saying here that If you fail to accept the null hypothesis when the p-value is greater than 0.05, when you fail to accept, then you are rejecting it. That rejection is false rejection. That is error 1. Conversely, if you fail to reject the null hypothesis when the p-value is less than 0.05, they are saying that that acceptance is false acceptance. It is called error 2. So you've known what error 1 is and error 2 is by Neyman and Pearson. That's not what I'm talking about here. Here I'm talking about error 1, type 1 error, type 2 error, type 3 error, which is basically what I refer to as objective errors. So what we're doing today is we're talking about objective errors. These errors make the entire work a joke. If you undergo this error, if this error occurs in your work, it is unscientific, it is unacceptable. The recommendation which will come from your result of analysis will not be taken seriously. What are these errors? These errors are, number 1, they are called type 1 error. Number 2, type 2 error. And then number 3, type 3 error. Now let's start with type 1 error. What's it all about? Type 1 error says that this error occurs when any of these two I'm going to mention now in any empirical research work takes place. Any of these two. What are they? Number 1, when the number of research respondents are too small. Say if they are less than 30%, or 30% rather, in the case of a macro study. Macro study means you're studying about institutions, governments, you're studying about policies and all that. So if the respondents, those that will give you the information upon which you are going to analyze, called the data, if the number of persons you administer the questionnaire to are less than 30, then there's possibly going to be an error, a type 1 error. And then we are also looking at the second part is another one that you should avoid in that type 1 is when the research respondents administered the research instrument. In the case of a micro, the former one was macro. If these people, the number you're going to administer the questionnaire to are less than the sample size, then there's an error. Why? Because the opinions of the respondents is expected to represent the total population, the general population, or the general opinion of the population, the total number. So if you say you have 30 persons, and what is the sample size of 30 persons? If the sample is say 25, then it should administer to 25. But if it is less than that, it is assumed that no, the opinion of those people you gave, which is less than the number of sample, cannot be taken as true and fair. So that is type 1 error. Now, for type 2 error, we are saying that these are errors that occur when the study data is not properly analyzed, or the right analytical tool is not used for the analysis. I repeat, when the analysis which you carry out in your study is not proper, you did the wrong analysis, or the analytical tool is wrong, you didn't use the proper one, then it is type 2 error. The example is number 1, the use of non-parametric tools like Candles, TWAB, like Spearman, chi-square for correlational analysis are not encouraged. They are judgmental and they are not selective tools. Don't use them for job or for work, for analysis that you know you are going to carry out a critical judgment or recommendation. Type 2 error. Yeah, we're still on type 2 error. Number 2, you look at if they work, a wrong analysis could also cause type 2 error. Wrong analysis. Now you did it right, you used the right parametric tool. Now you did the wrong analysis. Let me speak the Latin. It says exempli grante. For example, when you carry out a correlational analysis and conclude from the output or from the outcome of that analysis that correlation has been, hypothesis has been analyzed, that you have conducted an hypothesis. No, a correlational analysis is only meant to find out if the variables have linear relationship. So if there's no linear relationship, you cannot carry out an hypothesis on regression. You can't carry out a regression analysis. The regression simply means on a straight line. On a straight line, if both variables are linearly correlated. So if you make such a mistake, it is type 2 error. And now, if you use a parametric and non-judgmental tool like Karl Pearson's product movement correlation coefficient PPM CC, this tool does not analyze the variables if the dependent variable is or dependent variables are not normally distributed. You know, I'm giving you, this is telling you the reason why you should use a non-judgmental tool, a parametric tool, because if you carry out a correlation or a regression, it will not regress if it is not, if the dependent variable is not normally distributed. Now, type 3 error, what is it all about? It says that this error occurs when the output of the analysis is strongly interpreted. So the wrong interpretation of the output is type 3 error. This error is purely on interpretation of results. So if you don't give the right interpretation, even when you did the analysis properly, even when you carry out the right tool, even when the population, or the better still, the correspondents are up to the sample size, if the respondents are up to the sample size, and if in the case of a macro study, if the respondents are even up to 30, but after carrying out the analysis properly, your interpretation also matters. This is where Neyman and Pearson's type 1 and type 2 error comes in, because they are talking about wrong rejection and wrong acceptance. So if you do that, then if you wrongly interpret it, that is type 3 error. So note that the type 1 and type 2 error of Neyman, Jersey, and Pearson of 1993 fall into this category of type 3 error generally. So the error I've just spoken about, it is the objective error. What Neyman and Pearson were talking about is null hypothesis error. And this study is not for non-hypothesis error, it is for objective error. So these 3 errors I've mentioned here, type 1 error, type 2 error, type 3 error, should be avoided in a work. In subsequent lecture, I'm going to tell you how to avoid them. They are very important. If you make any mistake, well, your recommendation will not be taken very seriously. I want to say thank you for listening, and this very station, or better still, the YouTube channel, can be subscribed by you. You can like it, and once that is done, if there's a subsequent one, of course, you will be notified by YouTube operators. Thank you so very much. As I said, this very channel is purely for research methodology, taking you through the length and breadth of research methodology. If you have any question, please don't hesitate. Send your questions to Abel Simeon on my WhatsApp line +505-232-46646. That is my WhatsApp line. It's right there on the screen. Thank you for listening.